Linear inequalities. With linear equalities, you treat the inequality like an equal sign. There are 4 different types of inequalities that you can have, and I'm just going to write them in the middle here. You can have less than or equal to, greater than or equal to, and greater than. Okay, they're the 4 different types. Just to remind you on which one is which when you are looking at them. If you put your hand, okay, directly over the sign, this is my left hand, okay, and you can see that that triangle fits within my index finger and my thumb. That's less than to the left. Okay, the second one is less than, and with the line underneath it, it means less than or equal to. Other direction now. So this symbol, okay, my right hand fits on it, and that's greater than, going to the right hand side, greater than or equal to, and the last one there, again, is just greater than. Okay, if you use your left and right hand, just it's a great way to remind yourself on which one is which. So that aside, we're going to solve the question up on top here. Like any question, you try and deal with it by getting letters to the left and numbers to the right of whatever the symbol is. So whether it's an equal sign or an inequality, getting all the letters to the left. Okay, so starting off, 8x. You want all the x's to the left, so that means that 2x needs to come over and it becomes a minus 2x. Less than or equal to is next. We have 19. Bring over the minus 5 becomes plus 5. So when we solve this, 8 minus 2 is 6. Is less than or equal to 19 and 5 is 24. And x, when you get it on its own, you get rid of the 6 by dividing. 24 divided by 6 is 4. Okay, now that we have this, okay, we can draw our number line. So you're often asked to complete a number line once you have solved the equation. I suppose the easiest thing to remember with this is whatever number you get, pop that in the middle. And do a few numbers to the right and a few numbers to the left. Okay. Now, we were told at the very start of this question that we're dealing with the numbers of n. N are natural numbers. And natural numbers are shown as dots on an natural numbers, shown as dots on the number line. Okay. If you were ever asked about integers, that's the letter Z, they are also shown as dots. Okay, so 4, that's where I'm starting. X has to be less than or equal to 4. Because it's equal to 4, we include 4. Less than 4 would be like 3, 2. If 1 was on my number line, I'd include 1 as well. But you wouldn't include 0 because 0 isn't a natural number. So the numbers that are less than or equal to 4 would be the numbers 1, 2, 3, 4. Okay, and that's that question fully finished. The second question, okay, is very much the same, only that obviously our answer at the end has to be real numbers, but it involves a little bit of multiplication beforehand. 3 by k is 3k. 3 by minus 4 is minus 12, is less than 5 by k is 5k, and 5 by minus 2 is minus 10. Don't forget the minus 7 at the end. Okay. Like we did the last time, we want letters to the left and numbers to the right. So we're moving all the letters to the left. So all the k's need to be on the left-hand side. So when you move over the 5k, it becomes a minus 5k, less than. When you add those two together, that's minus 17. Bring over the minus 12, it becomes plus 12. Okay, we'll simplify this. 3 minus 5, you can pop it on the calculator, is minus 2k, is less than minus 17 plus 12 is minus 5. Okay, it's at this point where some people kind of get confused. When you change one sign, when you change one sign, you must change all signs. And this includes the inequality. And it's something to bear in mind when you're dealing with inequalities. So if you have a negative letter, you can't have a negative letter. So if you change that, I'm changing this now to plus 2k, I'm changing the minus 5 to a plus 5. But I also need to change the inequality. So it was less than, it's now going to become greater than. And I can solve it as normal. K is then greater than 5 divided by 2, and k is then greater than 2.5. Okay, you can pop that on the calculator. It's not uncommon to get fractions when you're dealing with solving equations, so don't think you're wrong the minute you get a fraction. It could be correct. Is that all right? Once we have this done now, we can now draw our number line. Okay, and in drawing our number line, we don't show fractions on the number line. We show the whole numbers, kind of like we did up earlier on. 2.5 comes between the number 2 and the number 3. So they're the numbers that go in the middle. Okay, then show a few numbers to the left and a few numbers to the right. Apologies, I did that the opposite way around, but anyways. Okay, so I have numbers 0, 1, 2, 3, 4, 5 on my number line shown. I have to show 2.5 on my number line. It's not including 2.5 because I don't have the line directly underneath it. But I need to show 2.5 on the number line because it is a real number. Because there is no line, it is an open dot. And you can see I've directly between 2 and 3, that is 2.5. I've shown all the numbers that are bigger than 2.5, so like 2.6, 2.7, 2.8. It is shown as a thick line on the number line because real numbers includes decimal places, fractions, everything. Okay, so that is my number line complete for real numbers. As I was saying earlier on, natural numbers are shown as dots, as are integers, the letter Z. Real numbers are shown with a thick line. It is an open dot if it doesn't have the equals to underneath the inequality. If it does have the line underneath, you would show it as a closed dot. Is that all right? So that's all the different things you could be asked on those.